Hello everyone, welcome to CMST290, Scientific Programming, Machine Learning. This is going to be our last lecture for the semester, last lecture for the class. And we're going to do a quick temp check on where we're at, take a look at the syllabus, and then see where we've come from, and then we'll do, and where we're going to end up with for today. So we've gone through weeks 1 through 2, weeks 3 through 4, weeks 5 through 6, which has been heavily focused on programming and programming labs. And then week 7, which we are just wrapping up now, and we're going to finish up with this last learning activity, which is learning activity 16, application of machine learning. And then we'll have a final quiz that's going to be opened up here in a bit, and then you'll have the whole week to take it. It'll be due on 7:30. And that'll be the last assignment. So that pretty much wraps everything up for the course. Congratulations if you got this far. I know it was, even though it's a 1 credit hour course, we packed quite a bit into the one course. So for this lecture, I'll just have you sit back and listen to me run through this final lecture where we're going to jump into the applications of machine learning, and that'll pretty much wrap up everything we've got going on today. So, all right, and for this semester. So, first off, we've done this. So think of this as a recap. So this is going to give you an overview of a little bit of everything that we've done through, which has been heavy on the programming, but this is going to be jumping into giving some additional resources, additional insights and thoughts to think through. And then also don't forget, this will be, some of this stuff will be on the final quiz. So don't, make sure that you listen to this lecture and get through the lecture, because parts of this will be on the final quiz. Okay, so definition of machine learning as defined more recently by Naka and Murphy here, Naka and Murphy. Machine learning, and this, honestly, this is a definition that, I mean, we could find in a lot of other definitions, but this is a good one and I like it, so we'll go with this one. But machine learning is an evolving branch of computational algorithms that are designed to emulate human intelligence by learning from the surrounding environment. So it's a good definition, and so when you look at this, and what we've learned today, we went through computer programs. We learned how to do some basics of programming, and then we implemented some computational algorithms, specifically some specific machine learning algorithms in code using scikit-learn to emulate or do pattern recognition or clustering. And so we've emulated what humans can do through code, high level. Of course, it's a really large field with a lot of specialties. So to give you the historical context, we did cover that earlier this semester. Don't forget, we went through and we developed an idea, both historical and cultural, the ideas of and the underpinnings of where artificial intelligence comes from, right? That we have for a very long time as humans been very obsessed to a certain extent with these ideas of artificial things, artificial machines. And it shows up actually in our literature many years ago. So don't forget our early lecture on that. And then we've also talked about the importance of machine learning and how it's changing our landscape today. Now, I'll talk a little bit more of a few more applications and examples in this lecture. So let's go ahead and do a little bit more recap before we jump into that. So don't forget that we also have many different types of machine learning. There is supervised learning, which we did in class through code, a single example, again, high level. Then we did another one, an unsupervised example. But then we talked about reinforcement learning through a lecture. So don't forget that we also learned about, not in code, but we did learn in the lecture what reinforcement learning looks like. And then don't forget, or I should say, let me add that there are also these other ones that are called semi-supervised learning strategies. And so in these cases, semi-supervised is it's a combination of both. It's a hybrid. There's also many other different types of machine learning algorithms. And if you go, there's some resources out there available. I've put them down here in the references list. I'll also do a recap on the references list at the end. So also don't forget that we also have, as it relates to those different types of machine learning, we had different algorithms that we implemented. So in this case, regression, classification, clustering, and then we did not do dimensionality reduction, and we did touch on neural networks in a lab, but not in code. Remember, TensorFlow, that was an artificial neural network, and we used TensorFlow's playground to explore the context of rectified linear units, as well as hyperbolic tangents and action potentials as it relates to neurons. And so we went through all of that. But we did not go through dimensionality reduction. That actually is something that we do when we're working with high dimensional data sets and we want to reduce them into 2 and or 3 dimensions. Usually we would use an algorithm called principal component analysis, or T stochastic nearest embedding, which is another algorithm that we use. But excuse me, in this case, we did not cover that, but that's something that we cover in more in future sessions, and or if you're interested in learning more. Of course, we have our full machine learning and autonomous systems bachelor's program, as well as master's program, graduate program that you might be in. So you'll get to learn more about all these different things if you decide to take it down that route. This being introductory, we can only cover so much. But knowing that there is regression, classification, clustering, we did do regression. We did a simple linear regression example, and we did a simple clustering exercise. And so clustering, so just as an FYI, the difference between clustering and classification, clustering uses no training data, whereas classification uses training data, even though that they are doing kind of similar things. But we did do a clustering and regression in code for this course. We did not touch on classification, but that's okay. Again, that's one of those things that you'd want to dive into later on in further follow-up studies. Okay, real-world applications of machine learning. There are many. If you go out on scholar.google.com, you will find many applications, many applications of machine learning, just from every industry you can think of. It used to be, if you backed up 15 years ago, that it was like, well, who's using it? Is it being used? Where is it being used? It wasn't really as predominant as now. Machine learning is used in every industry now. It used to be like some of the more advanced industries like space, transportation, logistics, where there was a lot more money that could be had in applying machine learning. Nowadays, you see it in healthcare, you see it in finance, you see it also in image and video analysis, autonomous vehicles for uncrewed ground vehicles, uncrewed air vehicles. There's just a lot out there. There's also a newer one, I shouldn't say newer. It's been around for a long time, but it's gotten a lot more advanced with ChatGPT, which is natural language processing. And it goes beyond just chatbots and virtual assistants. NLP and large language models, or LLMs, have taken the world by storm. I mean, they're just huge, and there's more advanced versions of ChatGPT. GPT is old by what's coming out today by today's standards. There's so many different there's just so much available out there in that world. So it's really changed the whole game as it relates to artificial intelligence in general. And I highly encourage people to do a lot more research in this area. Okay, next up, machine learning in marketing and customer service. I mean, from recommender systems on Amazon, customer segmentation, again on Amazon, the ability to do churn prediction, sentiment analysis, all of that, right? Amazon's doing it and doing it well. And it's not just Amazon. It's all the major market players, whether it's Microsoft or Google, your preferred search engine of choice. They're all in this business of customer service, and there's a lot of money to be made in this. Again, it's a big area, and probably an area where early versions of single algorithms or maybe a handful of algorithms were used. I know from my perspective, if you back up, almost 10 years ago now, we were using machine learning algorithms, really kind of more in isolation on both customer segmentation as well as prediction, what we call cash to, or quote to cash predictions. In other words, from a customer prospect, what is the probability that prospect turns into an actual paying customer? So there were things that we did years and years ago, but they were kind of more in isolation. Now we did a lot of the more successful players who got into machine learning early are doing well today, and the ones that aren't doing so well today. So machine learning is big, and it's going to be here to stay. It's here to stay, rather, and here to stay in a lot of different venues. All right. Last but not least is, and again, this is just not a comprehensive list. This is a high-level list of what's available and out there. But machine learning in manufacturing and the broader industry. So whether it's car manufacturing, additive manufacturing, biomanufacturing, you name it. Anytime we're using machines, there's machine learning within the machines, but there's also machine learning that's happening at a process level. So think of it kind of more as systems engineering, right? If I've got all this interstitial glue that connects electrical engineering, let me back it up. Electrical systems with mechanical systems, with computer systems, with all these different systems. You have systems engineering, this design and dynamics that occurs in the middle. The interstitial glue of the entire system itself has machine learning that is running around it and within it and in between it. So when you look at what's going on, it's not just for manufacturing for predictive maintenance, but it's supply, like it shows here, supply chain flow optimization. But it's not just at a manufacturing level. This goes a lot broader. There's a lot of increased hyperconvergence around machine learning, and it's going to be continuing. All right, now this all brings up really good, interesting points. Now I can't cover this. This actually can. I've seen it. It's been taught as its own course. There is a lot of research both on the bias and fairness of using AI, transparency and explainability of AI, as well as privacy concerns. There have been instances of AI used in for nefarious purposes, and it brings up a lot of good points. So I highly encourage people to be considering both the ethical ramifications of what it is around machine learning and artificial intelligence in general, because it's not just amazing and always fantastic. And some of this, whenever there's a new technology, and especially something like this, it can bring about some real world challenges and ethical challenges. And so these are just a couple. There are many more, and of course we can see many more in terms of deep fakes that show up on the internet, as it relates to reuse of people's images for nefarious purposes, and using AI to create even situations where things aren't fair, right? People who have access to AI versus people who don't have access to AI is going to be a very real issue, because the people that have access to, of course, the internet, but then can pay for access to premium AI services, are going to have a leg up versus other people that don't. So these are very real, I mean, social ramifications that don't even show up in the technical stuff we're talking about here. So those are kind of things to think about as we go along in the process. But that's enough for us to talk about, at least high level, from an ethical perspective on in this course. Okay, so challenges for the future as it relates to machine learning. There of course there's always areas to grow, areas to get better with, from performance to quality to maturity to interoperability. These are all things that we're in continuous improvement on. And don't forget, we also use machine learning for integration with other technologies like cryptocurrencies and things like that. It's as well as edge devices around Internet of Things. And so there's a lot of stuff that's still open territory, and will be for the next many hundreds of years, because this is a new, I mean, this is new for us, but this is an area that is gonna wildly change humanity. I mean, our ability to use an AI to, one of the things that we used to have a problem with in the past was we were creating data at a rate that was, and we still are to a certain extent, we're creating data at a rate that moves beyond our ability to analyze it and make sense of it. Now, with these large language models, we're actually starting to make sense of all this data that we've been putting together, that humanity has been putting together, that we've been cultivating and curating, and just rapidly creating an immense amount of information. Now, we are still to this day creating more data than we can handle, but these new AIs that are coming out, these large language models like ChatGPT and AutoGPT, and Llama and Bard, from the different vendors that are out there, they are creating a mechanism that actually allows us to start to make sense of everything that we've got out there, being able to draw inferences between various data sets that we wouldn't otherwise be able to see, correlations that we wouldn't be able to see. Now, again, we still have a long way to go, but it's an amazing start. So there's definitely a lot more challenges, but it's also looking very bright for us. I'm very excited in that regard. It's not all doom and gloom. There's definitely, it's very exciting time in that regard. Okay, with that, I'm just going to kind of recap. I think it's helpful to know where artificial intelligence is as it relates to machine learning, as it relates to deep learning. There's a nice little graphic over here that kind of gives you an overview of everything that we've really talked about, from AI to ML to DL. And we've touched on each one of those throughout this course. We've also talked about the potential impacts on various industries here in this last lecture. And then I've got something coming up here on the next slide to kind of give you some things to read up on, and things to explore, because we've explored machine learning through the more predominant framework known as Python for coding of machine learning frameworks. I'll give you some resources that can kind of further you along in that area. And if you are interested, here's the references. So these are the references in a list that were used here in this presentation. And then on the right, I've got some additional resources for you to take a look at and explore. From Python for Beginners, the python.org website, PEP8 style guide for Python, as well as the scikit-learn, which you're familiar with. A little bit of info on large language models. I felt like it might be helpful if you wanted to peruse the Wikipedia page on that. There's a lot of great information there. Also, if you're interested, there is a YouTube video on AutoGPT that's kind of fun. Gives you a little bit of info on what's the latest, right? I mean, because ChatGPT is 2 years old now, and it's showing some age. As well as don't forget scholar.google.com. There is a lot of great information out on scholar.google.com. I highly recommend it. You can find it's a wealth of information, a huge repository that is an index aggregator of all the research, not just on machine learning and artificial intelligence, but everything you can think of that you can ever imagine, you will spend. It's one of the best libraries on the planet. Okay, with that, thank you for getting all the way to the end of this course. I really appreciate it. I enjoyed it. I look forward to seeing everyone sooner down the road in different programs, whether it's in computer systems, whether it's machine learning, whether it's in the integrated systems design and dynamics course, or whether it's in space systems. I'm super excited to be here as your pilot for this course, and I look forward to seeing you in a future class.